Night settles over a high desert plateau, the air so clear it feels newly made. Above the basalt horizon, the Milky Way unfurls like a river of crushed ice, each shimmer a sun older than our species. At first glance, the cosmos appears honest. What glitters is what matters. What is dark is simply empty. Yet aim a telescope at a pinwheel galaxy, and numbers begin to disagree with eyes. Stars at its rim orbit as swiftly as those near the hub, racing along tracks that visible gravity cannot reinforce. It is as though an unseen orchestra section plays fortissimo, driving the dance while refusing the spotlight. Slide the viewfinder towards two colliding clusters, the bullet cluster, where pastel X-ray clouds of hot gas lag behind the collision while gravity's grip races ahead, mapped by faint distortions in background starlight. Here, mass and light divorce with startling clarity. The heaviest actor wears an invisibility cloak. And while astronomers pondered that hidden pull, another puzzle drifts across the stage. Supernova, stellar detonations that should dim in a steady rhythm, appear to faint for their distances, signaling that space itself is stretching faster every epoch. As though an intangible wind were pushing galaxies apart with patient insistence. Together, these clues scrawl a cosmic graffiti. Something unseen binds galaxies. Something even more mysterious pries them away from each other. One tugs without shining, the other pushes without touching. Their combined dominion approaches 95% of the universe's energy budget, leaving all stars, planets, and poems to share the remaining sliver. We have given them tentative names. Dark matter for the hidden mass, dark energy for the silent shove. But the labels are confession, not comprehension. Placeholders marking the edge of knowledge. Yet ignorance can be generous. It invites wonder, humility, and the thrill of pursuit. Tonight we will follow the faint fingerprints of darkness, from Vera Rubin's quiet rotation curves to the ghostly lensing maps that reveal mass where no telescope sees light. From the acoustic ripples frozen in the cosmic microwave glow to the Type Ia flashbulbs that first betrayed an accelerating sky. We will watch supercomputers grow galaxies on invisible scaffolds, descend into underground caverns where tanks of liquid xenon wait for the gentlest knock, and peer ahead to missions that will weigh the cosmos with gravitational waves and crimson-shifted hydrogen mist. Our journey is not solely scientific, it is also personal. Every breath, every childhood memory, every act of love unfolds within a universe governed by entities we have never directly beheld. To understand them is to understand the home that cradles us. So let the desert night deepen. Let the silence sharpen the stars. And join me in listening for the music beneath the darkness. For in that music lies a double riddle. What invisible hand grips the galaxies? And what unseen tide carries them apart? The answers, still unsigned, wait somewhere between the starlight and the shadows. A winter night in the Arizona desert. Thin, sparkling air, the whir of an old spectrograph. And Vera Rubin, pressing her eye to the guiderscope, one by one, she charted the Doppler shifts of stars wheeling through the Andromeda spiral, expecting to see the graceful Keplerian taper Newton would have predicted. Stars near the hub racing, those in the outskirts ambling. Instead, the curve refused to bend. Far-flung stars tore around the disk at the same breakneck speed as stars near the core, as though some unseen hand had tightened the whole galaxy to a single rumbling wheel. Night after night, the pattern repeated. NGC 2403, M33, M101. Every luminous pinwheel pinned to a flat velocity plateau, out up the glow of gas and stars, and their combined gravity was too meager by a factor of 6 to hold the rims in check. By classical reckoning, spiral arms should fray like straw in a gale, flinging stars into intergalactic dark. Yet the galaxies endured, serene and self-contained. Rubin's colleagues searched for mundane answers. Hidden clouds of cold hydrogen, swarms of brown dwarfs, observational error. None could pay the missing mass. The simplest explanation, unsettling in its simplicity, was that halos of invisible matter, vast transparent cocoons, enclosed each galaxy, contributing gravity and nothing else. Today, every child with a modest backyard telescope can trace those same curves, mapping the tug of an entity that neither shines nor scatters light. The lesson stands luminous in its absence. Galaxies spin on the strength of matter we cannot see. If rotating galaxies hinted at shadowy mass, the bullet cluster shouted. 2 titanic galaxy clusters, each 1,000 trillion suns in heft, met head-on some 3.8 billion years ago, passing through each other like spectral juggernauts. Chandra's X-ray eyes revealed the aftermath first, a bow-shock plume of incandescent gas, pink and turbulent, slowed and crumpled by the collision. But when astronomers overlaid a weak lensing map, subtle distortion of background galaxies by gravity, its deepest wells of mass were not draped over the glowing gas at all. They lay ahead of it, like blue ghosts marching through a battlefield unscathed. No tweak of Newton's inverse square law could conjure 2 separate centers of gravity where ordinary matter showed only one. Modified gravity might explain flat rotation curves under special circumstances. It could not split mass from light in this cosmic smash-up. What passed unimpeded through the wreck was something immune to drag and radiation alike, contributing most of the cluster's heft, while the luminous gas lagged behind. Follow-up collisions, El Gordo's fiery mashup, the sausage cluster's elongated scar repeat the spectacle. Hot baryonic matter slowed by shockwaves, invisible mass surging onward. Each scene drives the same verdict deeper. Gravity's dominant player carries no charge, no glow, no heat, only pull. Here, across millions of light years, and at temperatures hotter than stellar cores, the cosmos performs a decisive experiment we could never stage on Earth. Matter, we can see, separates cleanly from matter we cannot, leaving gravity to choose its favorite dance partner, and it chooses the dark. Step back in time, not by centuries, but by 13 billion years. The cosmos resembles a hot fog of light and plasma, as even the densest stars today could not imagine. When that fog finally thinned, the first light able to travel freely went sprinting in every direction. We still bathe in its afterglow, and astronomers call it the cosmic microwave background, or CMB, a faint radio haze that fills every inch of sky. Zoom in on that haze and you notice it is stippled, ever so slightly, with warm and cool blotches. Those blotches record sound waves, pressure ripples that once rang through the primeval gas. Think of a cosmic drum. Gravity pulled matter inward, light pressure shoved it back, and the push and pull left a subtle fingerprint. When satellites like Planck and WMAP measured that pattern, they extracted a kind of barcode, peaks and valleys telling how big each ripple grew before the fog cleared. Here lies the surprise. The location of the first peak says most of the universe's mass must have gathered into lumpy knots. The second and third peaks answer, but only a small slice of that mass can be the ordinary atoms that make people, planets, or starlight. Run the numbers and you find ordinary matter accounts for about 1/6 of what gravity demanded. The remaining 85% must be something quieter, something that felt gravity but ignored light entirely. So the oldest light we possess, rather than revealing everything, instead whispers a riddle. Most of what shaped those ripples never glowed at all. Einstein once compared gravity to a bend in the fabric of space-time, and nowhere is that bend clearer than in the sky's ghostly mirages. Point a powerful telescope at a distant quasar, an ancient beacon billions of light years away, and sometimes you see not one point of light but 2, 4, or even a perfect ring. There is no glass lens floating in the void. Instead, a hidden mass in the foreground has curved space itself, steering the quasar's light into multiple paths. Astronomers call these apparitions gravitational lenses. In many cases, the foreground galaxy or cluster is far too light on paper to create the lens we observe. It is like finding a child's magnifying glass, turning street lamps into searchlights. Detailed maps made with a technique called weak lensing, which measures tiny coherent stretches in the shapes of thousands of background galaxies, show broad halos of gravity that extend well beyond the visible stars and gas. Whole ghost halos hang around clusters, massive enough to warp starlight, yet transparent as air. Even on smaller scales, single stars amplify distant planets by microlensing, producing telltale brightening that detectors in Chile and New Zealand catch a few times each year. Some of these brightness jumps reveal lenses heavier than any lone star could be, hinting at compact clumps of unseen material adrift in the Milky Way. Gravitational lensing is, in effect, the universe's inkblot test. Light bends. We read the pattern. An invisible matter steps into view by the shadow it casts on geometry itself. Together with the CMB's ancient barcode and Rubin's spinning galaxies, these arcs and rings form a chorus, each voice different, the song identical. There is more out there than meets the eye. Gather every clue we have. Rubin's steadfast stars, the CMB's primordial barcode, clusters colliding like ghosts, and quasar light bent into cosmic necklaces, and lay them side by side. Each points to an unseen scaffolding, but none yet reveals its shape. To picture that shape, astronomers turn to the largest laboratory we possess. The universe itself, replayed inside a supercomputer. A simulation begins modestly, with a smooth fog of dark matter particles and a whisper of primordial ripples. Press start, and gravity does the rest. Dark clumps seed filaments, filaments braid into vast highways, and like dew beating on a spider's web, galaxies light up, only where those invisible strands knot most tightly. When the computation ends, scientists compare the simulated map with real surveys that chart millions of galaxies across billions of light years. The match is stunning. Voids, walls, and clusters align as though the dark lattice were traced directly onto the night. And so, a picture comes into view. Ordinary matter is the frosting, not the cake. The luminous cosmos rides on hidden ridges that dictate where stars will shine, where gas will cool, even where life may one day emerge. The question is no longer whether this silent architect exists, but what it is made of, and how it sculpts such grandeur. In the next part, we will dive into that grand design following the unseen sculptor from the first heartbeat of the universe. To the spiraling cities of galaxies we inhabit today, we'll watch darkness pull the strings and light dance obediently in its wake.